In ancient Syracuse, Archimedes faced a royal puzzle. Was the king's golden crown pure, or had the goldsmith cheated by mixing in silver? The king demanded proof, but melting the crown was not an option. Archimedes pondered the problem everywhere, knowing gold is denser than silver, but how to measure the crown's volume without destroying it. One day, as he stepped into a full bath, water spilled over the edge. In that moment, he realized the volume of water displaced equaled the volume of his body. Eureka! He could now measure the crown's volume by submerging it and comparing the water displaced to that of pure gold. Archimedes' insight revealed a hidden law of nature, the relationship between objects, water and floating. This was more than a solution for a king. It was a breakthrough in understanding why things float or sink. His discovery would echo through science for centuries, and it all began with a simple splash in a bath. Archimedes' principle states, any object submerged in a fluid is pushed upward by a force equal to the weight of the fluid it displaces. This upward push is called buoyant force. If an object's average density is less than the fluid's, it floats. If more, it sinks. Imagine a block of wood in water. It floats because it displaces enough water to equal its own weight. A pebble, denser than water, sinks because it can't displace enough. Archimedes used this principle to test the crown. He compared the water displaced by the crown and by pure gold of the same weight. The crown displaced more water, proving it was less dense. Silver had been mixed in. The king's suspicion was confirmed, all thanks to a bath. This principle explains floating and sinking everywhere, from leaves on a pond to massive ships at sea. It's a simple law with immense consequences, and it all comes down to density and displacement. How do massive steel ships float? It's all about average density. A ship's hull is mostly hollow, filled with air, making its overall density less than water. The ship sinks only until it displaces a volume of water equal to its own weight. Then buoyancy holds it up. Submarines use the same principle with ballast tanks. To dive, they fill tanks with water, increasing density. To rise, they pump water out, replacing it with air. The balance between gravity and buoyancy lets these giants move above and below the waves. Archimedes' principle is at work in every vessel, from cargo ships to submarines. It's a dance of physics, engineered for control and safety. The same law that solved a king's riddle now moves the world's fleets. Every floating marvel owes its existence to that ancient discovery. The principle is as powerful today as it was in Archimedes' time. Archimedes' discovery shaped the science of hydrostatics and revolutionized engineering. Every ship, oil rig, and even hot air balloon relies on his principle, floating in water or air by displacing fluid. The law applies everywhere. A toilet cisterns float, a balloon in the sky, a ship at sea. It's a universal rule quietly at work in our daily lives. Archimedes' Eureka moment is a cornerstone of science and engineering. His insight lets us cross oceans, explore the deep, and soar among the clouds. Sometimes, the greatest discoveries begin with a simple observation. The legacy of Archimedes' bath continues to buoy the world, and the cry of Eureka still inspires discovery today.